we will have a tutorial on how you can identify quadratic equation. Let's proceed. So what is a quadratic equation? Quadratic equation is in the form of ax squared plus bx plus c equals 0. And as you can see, this ax squared plus bx plus c equals 0 is also known as the standard form of the quadratic equation, wherein a, b, and c are real numbers and a should not be equal to 0, because when a is equal to 0, then the equation is considered a linear equation. It is also known as a second degree equation. Why it is a second degree equation? Because of the exponent 2. The highest exponent is 2 in a quadratic equation. Where ax squared, or the first term in the trinomial, is the quadratic term, bx, or the second term, is the linear term, and c is the constant term, wherein when we say constant term, there is no variable found in this term. Next, so let's have our first example. We have here 2x plus 5 equals 0. Is 2x plus 5 equals 0 a quadratic equation? Let's check. This is not a quadratic equation because, as you can notice, there is no exponent, or there is no term of an exponent of 2. The highest exponent, or the highest degree found here is 1, and that 1 is found here. Okay, so this one is not a quadratic equation but a linear equation. Next, let's have 2x squared minus x minus 1 equals 0. Is this a quadratic equation? Yes, this is a quadratic equation because it is in the standard form of ax squared plus bx plus c equals 0. And the highest degree of exponent, or the highest exponent, is 2 here, as you can notice. And the value of a is 2, b is negative 1. If there is no number beside the variable or the letter, then it means it is understood that there is 1. And the value of c is negative 1. We can also say that this is a complete quadratic equation because it has 3 terms. Is that clear? Next, let's have x squared plus 9 equals 0. Is this a quadratic equation? Obviously, yes. Does it follow the standard form? Yes, but it is not a complete quadratic equation because, as you can notice, there are only 2 terms on the left side of the equation. Is that clear? And also, the highest degree is 2. That's why it is also considered a quadratic equation. Now, what are the values of a, b, and c? A is 1, b is 0 because the linear term is missing, and c is equal to 9. Another example. Let's have negative 5x squared equals 0. This is also a quadratic equation but an incomplete one because, as you can notice here, the left side of the equation is just a one-term or a monomial. It is a quadratic equation because the highest exponent is 2. And the value of a is negative 5, b is 0, and c is also 0. How about this example? Would you consider this one a quadratic equation? This one is a quadratic equation, yes, because as you can notice here, the highest degree is 2. Yes, you're right. Once you see that there is an exponent that the highest exponent is 2, the equation is considered a quadratic equation. And as an emphasis, when there is an equal sign, it means that is an equation. Okay, but this particular equation is not in the standard form. So we can transform this one to the standard form. So how do we do that? By applying the addition property of equality or the transposition method. All you have to do is to transpose 5x squared to the left side of the equation. That is why 5x squared becomes negative 5x squared. Copy 3x minus 4 equals 0. Would you consider this now a quadratic equation? Yes, and it is now arranged in the standard form. Now, we have to multiply it to negative 1 because a quadratic equation is properly written when the value of a is positive. So, we multiply both sides by negative 1. The equation now is 5x squared minus 3x plus 4 equals 0. And the value of a, b, and c are 5, negative 3, and 4 respectively. Another example. We have here the quantity 2x plus 3 times the quantity x minus 1 equals 0. Is this a quadratic equation? Obviously, it is not a quadratic equation yet, but it can be transformed to a quadratic equation. Since we have here two binomials and the operation is multiplication, all you have to do now is to perform a FOIL method. This lesson was tackled when you were in grade 8. So how do we do a FOIL method? F means first term. So we multiply 2x times x, you'll have 2x squared. Then we have O, the outer terms. That's 2x times negative 1, and you'll have negative 2x. I will have the inner terms. 3 times x, you'll have positive 3x. And 3 times negative 1, which are the last terms, is equal to negative 3. Then copy equals to 0. This is not the final answer yet because we need to combine these two terms because they are like terms. So we have now 2x squared plus x minus 3 equals 0 because negative 2x plus 3x is x. So the value of a, b, and c now is 2, b is equals to 1, and c is equals to negative 3. So the first equation can be transformed now to a quadratic equation.